Hello, welcome to a new video. Today we're going to solve this problem called Serialize and Deserialize binary tree, number 297, a hard problem LeetCode. I did watch a video on how to solve this problem, so I'll just kind of regurgitate what I learned and kind of a way to think about the problem and look at it from my own perspective. So yeah, I did watch LeetCode and I did watch Programming Live with Larry, my goat. Anyways, so yeah, after watching those two videos, I kind of studied like how to look at it and how they went through it. They went through with their first intuition. So I'm just going to showcase what I thought initially and then kind of tie it in together, I guess. So let's go read the problem. So serialization is a process of converting. So this is all like filler. Okay, so you can read that, but that's just like filler. Design an algorithm to serialize and deserialize a binary tree. This is kind of just the whole thing. They leave it pretty vague. By vague, they're saying there's no restriction on how to serialize or deserialize. You just need to ensure that the binary tree can be serialized into a string, and the string can be deserialized into the original tree structure. All right, so I guess there's no really input and output. I mean, yeah, there's no really input and output, but I guess like the input is the binary tree. So input BT, and then the other input. So there's two types of input. So serialize input is just a binary tree, and then output has to be a string, and deserialize input is just a string, and then output of that is going to be a BT. So I guess we can start with serialization. It's fine. Whole different genre. Anyways, so yeah, I guess first we can start off with this serialization, and then second can be deserialize. Because in order to deserialize, we need to serialize first, so that makes sense, right? So yeah, LeetCode also gives you clarification that the input and output that they give in the examples are the same as how they do it, and they say that we don't need to follow it, but I guess we can follow it because we're not creative enough, but we know how to solve it, right? So what they're doing here, let me just take some notes. So what they're doing here, as you can tell, it's pre-ordered traversal because they do current, left, right, right? See current, left, right. But in this case, we see that we access current, then left, then there's null. Because there's nothing here. Then we go right. Then yeah, it's kind of weird how they do it. I mean, it's kind of weird how they do it. I guess it should be like 1, 2, and then null, and then 3, then 4 null, then 5 null. But that's what they're doing here, as you can see. I think that's how they're doing it. It looks like it's pre-order to me, so I'm just going to assume that I'm going to also do a pre-order serialization. So to note, maybe we could do like pre-order. There's also note and match. So note, pre-order. Let's name it match. So we're gonna do pre-order, and then so for serialization, we'll return the binary tree into a string. We can return the string by using dot join, and then we can for their serialization, we can turn that string back into a list by doing dot split, right? Just to kind of cheat around, I guess. Turning a list into a string, turning a string into a list. So yeah, so that's what I'm gonna try to do. Let's go over some examples, I guess. But I guess we can use this as an example, even though I already said it. So we have 1, 2, 3, and then 4, 5. Right? So to deserialize this, we want to do pre-order, where we go current, then left, and then once we go all the way left, we have to go right? Because we call current here, then we call pre-order on the left, and it's like, okay, so I'm gonna go to my current, then go to my left, and then so on, right? And then once everyone has done their left, we go their right, and then now we're done with this for this route, and then we go right, and then this here is like, okay, I'm going to access my current, then I'm going to go left, and it's like, okay, I'm going to access my current, then go left, and then once they're all done with going to the left, so we go to the right. 3 is like, okay, I'm done with my left entirely because this is done with this left, this is done with this left, so I'm gonna go all the way right. And then 5 is like, okay, I'm gonna access my current and then go to my left, and then access my current, then go all the way go left. Then once they're done, they're like, okay, I'm gonna go to my right. And then now once it's all done, they're like, okay, 1, you're done with everything, so stop. So then we are done with the whole tree, right? So that's what we're gonna try to do. So I guess for an example, that kind of did it. But one thing I gotta note is that when we access, or when we go left or right, and and it's null, we gotta say that it's null, like explicitly for deserialization. So when we do serialize, it looked like this, right? It looked like this. So 1. Access 1, go left. 2 accesses, it's pre-order, so current left, right, but there's nothing there, so null, null, right? And then 1's like, okay, I'm done with my whole left. This is my whole left with pre-order. So now that I've done my left pre-order, I'm going to do my right pre-order. So what I'm going to do is I'm going to go to my 3. Then my 3 is going to call pre-order on itself, which is just access self and then go all the way left. So 4. And then 4 is going to be like, okay, I'm going to access myself, then do pre-order. So I'm going to access myself, do left, and then right. There's nothing down that's left, so we say that it's null. And then we access right, it's null. Then we have to go back to 3 because 4 is done. And then 3 is like, okay, I'm going to access my right with pre-order. Now it's going to access 5, which is going to access itself. And then 5 is going to call pre-order on itself, which is itself, left and right. So it'll just be null and then null because there's nothing there. This is how the list should look like. And then we're going to want to turn this into a string, right? And then give it back to our deserializer to deserialize it into a binary tree. And then now once we have this as a string, we're going to turn it back into a list. So we're going to have this exact same list, right? And in pre-order, we kind of already know what to expect, because we already know that pre-order accesses the current, left, and then right? But in this case, it's going to look weird because it doesn't look like how it's going to be like. But just keep in notes, I guess, that note the serialization with list that it's recursive, right? It's recursive. So what I mean is recursive. We obviously know that we're going to access the root first, right? So 1. And then we're going to go to the next element in the list. And we're going to be like, okay, so we know that 1 is already accessed. So we know that 1 has to go to the left, right? Because of pre-order, right? So you go 2. But then we know that, let's call pre-order on the left. On 2 also, right? So then we access null and null. So once we reach like null, that means that we're done with it, right? Right, because it's recursive. This doesn't mean that it's, because when I say like pre-order, right, you're also gonna say like this is current, then left, and then right, but that's not the case because it's recursive, right? So I call 1, or I go through 1. 1 has its one recurses, saying that we had to do pre-order on the left, which is 2. And then we know that we're done is when we reach null and null, right? When we reach this. So then we'll know to go to the right once we reach, or to go to like another subtree once we reach 3, right? Because we reach null and null here. So if we go 3, then 3 is like, okay, I need to do pre-order myself. So the next element will be my left, and then 4 is like, okay, I need to do pre-order myself. So the next element next to me is my left, right? And then okay, I reached null. So I reached null. So that means I should be the last. No, I reached null. So that means that this element doesn't have a left or right. So what I'm going to do is I'm going to go back to 4. I'm going to go back to 4. And I'm going to realize that 4 has a right, which is the next element. So null. And then once I know that I have null, then I'm done with 4 completely. 4 can go skip. And then we start again at 5. Because we are done with our left side because we just did this. So then 3 is like, okay, I have a right node, which is 5. It's not null, so I can just keep on going. So I'm going to say that 5 is my right node. And then I'm going to say, okay, I'm going to do pre-order myself with this 5. And so the next element in this list is going to be my left, which is null. And and then 5 is going to say, well, my left is null, right? So that means that this null won't have a left or right. So I can say that the next element, again, is my right. Right? And so on. So that's kind of like the example that I just did. So yeah, hopefully that makes sense. But that's how I kind of understood it and how their algorithm worked out for this problem. So I'm just going to copy and regurgitate what I said as a plan. With some pseudocode. So basically for this serialization, for deserialization, yeah, we're gonna do pre-order for deserialization and serialization, right? Serialization, for serialization, we're going to put it into a list. Input bt into list, right? List into string. So what I need to do is I need to create a list, right? So res is equal to an empty list, and then I'm basically putting it. Yeah, I'm basically doing like basic pre-order. So I'm gonna access first. So which is access. So pre-order is equal to access cur, then DFS, then go left, then go right. So that's what I'm going to do. So what I'm going to say, I'm going to create res, and then I'm going to make a depth first search function. So DFS. I'm going to put it up here so it makes sense. And then I'm going to say for base case, so base case, if null, then just return, oh, I'm putting it into a list, so I don't have to return anything. So if null, then I want to append, so res.append, what do I want to append? What do I want to append? Oh yeah, also we should ask some questions. So a question is like, what is the min value of node in binary tree? It is -1000. So I'm gonna say that. That null is going to be 1001. I don't know. I don't know. Just to make it consistent that the list contains everything of integers, right? Yeah, that makes sense. I think that makes sense. So so if null, then append 1001 to the list. But if it doesn't go to the base case, then I'm going to say just append, right? So res.append no.val, and then just go DFS on no.left and no.right. And I forgot DFS should contain node. We want to just go down the whole binary tree that we're given, right? And then that should be done. Then we should have this basically, where instead of n, just replace it with like 1001, I guess, to represent null. So to note, we're gonna say that null in serialization is equal to 1001. Okay. And then this should work. We're gonna have this exact same thing that we're doing here. And then I guess for serialization, to initiate serialization, we're just going to call DFS with the root we're given, and then return res, right? Because we want to take our input binary tree, turn it into a list, and but we need to turn it into a string. Oopsie. So I guess we have res, but we want to. Ooh, I'm gonna call this temp actually, temp, and then we're gonna have res is equal to an empty string. I guess, yeah, I think that's fine. I think that's fine, right? I think that's fine. And then we're gonna call DFS root, and then once DFS root has been called, so once called should be temp should be complete. And so once we have temp, we're gonna turn that into a string, right? Because we want to turn the list into a string. So we say that res is equal to res dot join. How do you to turn list into string? Okay, so I guess I can just say like I can do it at the end. So I can say that res is equal to like just dot join, right? And then I can join. I'm pretty sure I can just say join temp, right? So it's gonna separate it by space, and then return res. I think that's fine. So yeah, that makes sense. And then for deserialization, for deserialization, I want to basically our input is a string, turn that into a list, and then turn that into BT. Right, so yeah, so we're basically getting the serialization from res, from this over here. Okay, so we gotta turn this string into a list. So so turn list into string. So we say that what is it called? What's the list? It's called data. Okay, so it's called data. So okay, this takes in root. Okay, so turn list into a string. I mean, turn string to a list. So I have to say that split, right? Because I did it in the match. So I have to say that temp is equal to, it's kind of confusing, but temp is equal to data.split, and I'm pretty sure it's fine because dot split by default splits by space, right? Yeah. It's default by yeah, white space. Okay, cool. So that's fine. So temp is equal to the dot split, and then we're gonna have it back into a list, right? Oh, I should say like it's an int list because by default it's a string, right? So can I say put dot split for wait. Yes. So for let's comprehension for x in turn that into an integer. Alright, so this is basically list comprehension. List of ints. Right. Yeah, so for whatever is in data.split, we're going to turn whatever element in here into an integer x. So we're good with that. And now we just need to do what I did here, which is just pre-order a recursion, right? So to do that, I'm gonna need that first search, and then for base case. So for base case, so if how do I access into a list? Oh, I need index. So index is equal to 0. Okay. And then this needs to be non-local. So non-local index. Okay. So if temp at index is equal to 1001, then just return none, right? Because we want to make it into a binary tree, right? But if that's not the case, then we can just continue to solve the problem. We're going to call. Yeah, wait, actually, let me think. Okay, if that's not the case, then yeah, so I want to make a tree node. So tree node. And then I'm going to say that this tree node is going to equal to whatever value at temp at index. Right? And I'm going to call this node, I guess. Oh, is equal to that. And then how am I going to solve this? Okay, because when I first initially called the FS, it's going to make a node, right? And that node's going to be connected to every node, right? So I guess I'm going to just say return node. And then I'm going to say that node.left is equal to DFS. But how I know? Oh, yeah, I have an index. Yes, I have an index. So yeah, I have an index. So 0, and then when I call left, it's going to be index plus 1. So I have to say that index plus plus. Yeah, and here also. So index plus plus. So I can go to the next one as well. So this should work because it's going to in pre-order order as well. So it's gonna basically match this whole thing with this, and then this whole thing with this. So it's just in pre-order as well. So it should work no matter what. So node.right is equal to DFS. And then yeah, I think that makes sense. So let me just rerun this. So we have this. So node is equal to tree dot. So I'm gonna skip this base case because we're at 1. So then we have 1. Index plus plus, we're at this 2. Yeah, because we called left. And then we put that 2. And then no dot, and then you have to go no dot left, which is this null. And then it says this. So this is none. And then we're like, okay, So we already have node dot left. Let's go node dot right. It's none. So we just go increment. So boom, we're at this 3 now. And then now we're back up to this 1. Because we're done with node dot left for 1. So I'm going to go node dot right. And then we create this 3, increment index, and then go left, which is this. And then yeah, this should work. Just keep on going. So it's honestly just good code. But I'm just gonna copy and paste it back in here. That's a lot of code. Okay. Delete this. Alright, so serialization, which is just BT into a list into a string. So BT list into a string. Okay, so we want to get our list. Oh, I call it temp. Oops. Temp is equal to empty list, and then the fs with just node, and then if not node, then just temp dot append 1001, correct? Yeah, base case, but then just do pre-order, which we access the current. So temp dot append node dot val, and then we go dfs node dot left, and then dfs node dot right, and then I want to call dfs with root, and then just return temp. Oh no, we want to turn it into a list. I'm not following my whole. I want to turn it into a string. I'm not following my plan. So res is equal to this string. We're gonna join it with temp, and then we should just return res. And then this takes in a string. We need to turn it into a list. So I'm gonna say that temp is equal to list comprehension. So data.split, which is a list. Let's split it based off the default, which is just a space. And for x in data.split, we're going to turn x into an integer. And then we have our list. So now we can make that into a, we can iterate through that into a binary tree. So base case for a binary tree. So if we make a non-local I, so I is equal to 0, or index basically. So we say also say this is non-local. So if temp at I is equal to 1001, that means that element resembles a null node, so return none. And if that's not the case, then we're just going to yeah, we also have to increment. So we have to increment our index. So index plus equals 1. Then we can turn none. And then if that's not the case, we can just continue with pre-order. So we can just say that the node that we're going to create is a tree node, and it has a value of temp at I, right? And then we can increment our index by 1, and then go left, and then go right. So node dot left is equal to the return value of this, and node dot right is equal to the return value of this, and then we can just return node, right? And then we have to call dfs once, because it'll just iterate through this whole temp. And then yeah, and just I guess we can just return dfs. This should run. Oh, oops, and then return. Um, how to use that join? With string instance int found. How to turn and int list into a string. Python. Do I need to? Or do I need to say that they're all strings? Do I need to actually do that? So do I actually need to do that? X in temp. String X. Do I need to do that actually? Whoa, I didn't know that I didn't know dot join needed like a list of strings. Oopsie. Okay, but that's fine. So that worked. Let's see if it actually works. And it does. Yo. Thank you to LeetCode and Programming Live with Larry. You guys are my goats of all time. My greatest of all time. So yeah, so this is a Oven time Plexi solution. Because we're going through each node once. And serialization and deserialization. And for space, it is, I guess you could say it's O of n for serialization and O of n for deserialization because we're putting each node into a list, and then with temp we're putting each node, we're putting each value into a list, and then we're iterating through that list, right? So yeah, pretty much it.